So my name is Inanc Senocak. I'm an associate professor in the mechanical engineering department. I'm also the graduate director for the mechanical engineering program. So my area of research is computational fluid dynamics in general, and with applications in energy and environment. So I just want to talk a little bit about my lab and also my colleagues' labs as well. So we are computational. So what we will, general umbrella term is computational science and engineering, CSE. Our labs don't have expensive equipment in the sense that you get your hands-on experience. Some folks like to do that. But what we have is actually access to high-end computing resources. So we are lucky at Pittsburgh. We have two resources other than individual faculty having their own high-end workstation. We have Pittsburgh Supercomputing Center. This is a national supercomputing center that is walking distance from us. It's managed jointly between University of Pittsburgh and Carnegie Mellon. They do workshops, even though they are online. Our students actually can walk there and attend them in person and engage with the experienced staff there. So that's actually a very positive thing. Aside from that, our own university have the Center for Research Computing. So we have, again, these are, I would call them super computer as well, but oftentimes we call them clusters. And these are Linux clusters that have parallel computing capabilities with the CPUs and also GPUs, right? We're talking about millions of dollars of investment in these systems. And it also comes with parallel file storage. So we could actually play with very large data sets in an interactive fashion. We can visualize them, cut them, slice them, dice them, and get a sense of the physics that we do. So if you come to our lab, of course, it looks dry because all you have is a terminal computer and you log in there with your password, but you're actually logging into multi-million-dollar machines, basically. So that's a lot of privilege that not every university have. So that's something unique to us. And the other good thing, again, Center for Research Computing, CRC we call it, and they regularly organize workshops in person. There are workshops teaching you how to program in Python, R, MATLAB, Linux, how to use the clusters, how to submit jobs, etc. Right? How to visualize large data, how to visualize data remotely too. So sometimes your data is somewhere else, you know, maybe it's in one of the supercomputers in Texas, right? But you still want to be able to remotely render your data without pulling the data here, right? So these are the things that are available to us, and we constantly train our students, okay? So that's the resource, computing resource end of it. Oftentimes the research that we do involves a lot of the programming or working with an existing open source code or in-house code. So having background in a programming language, C, Fortran, C++ is always a bonus. But then there are other resources that you could actually benefit to get up to speed with those programming courses. So we offer courses in parallel computing, data-driven modeling, reduced order modeling, machine learning, where you get to actually practice your C programming, Python programming, MATLAB programming. So yeah, those are resources that are available to our grad students to build themselves. Visit the booth for computational resources and say hello. Even if you don't have any questions, our students will be happy to talk with you about our software and hardware resources, as well as the types of research we do. We are excited to see how you'll use these resources to conduct your own investigations as a graduate researcher.